What I'm going to talk about here can be done in software from different manufacturers. This presentation is more about to inspire you to use AI in measurements and calculation of DAB networks. As we all know, there are lots of numbers and information, and AI can help us do that much more efficient and use less time. The NRK DAB network is finished. We have 99.8% national coverage, but from time to time, we do get calls and emails from our listeners with problems receiving our DAB signals. It can be many reasons why they have problems, like a bad receiver, problems with the antenna, with weak signals, or they might have tuned to the wrong frequency if they are living close to another region. The NRK DAB network is divided into 7 regions, so turning to the wrong frequency is a common problem if you live in a border area. Mostly, we can resolve all these issues together with the listeners on phone or by email. But sometimes we need to go out and check the coverage. We have built the NRK network for these values. It's 42 dB microvolt per meter, we call that basic coverage. That's reception with a good external antenna and a good glass adhesive or original mounted antenna in the car. 48 dB microvolt is good coverage, generally good reception, including in wooden housing developments. 54 dB microvolt per meter, that's what we say is very good coverage. It's high probability of reception indoors and outdoors, also in urban areas. So I got a phone call from this little village. There was a man living here, and he could not receive radio on his farm. He claimed that he had tried several types of radios. The village is located here in the middle of the south part of Norway, at the longest fjord in Norway called Sognefjorden. So I looked at the theoretical coverage map, and I saw there were basic coverage there and also good coverage in most areas. But we had never been there before, and the signals in this village is based mostly on reflections. So the map could be wrong. When I go out, I have these tools. This ProMax, and there's a Rode and Schwarz. The ProMax is easier to handle and use when you're alone in the car. And I can also record the signals here. The ProMax and the Rode and Schwarz is not calibrated, so I have to add 14 dB to the signals on the ProMax to get the same values. It might be possible to adjust this in the ProMax, but I have not been able to do that. So after recording the measurements there, I get this XML file. And going through an XML file like this is a nightmare. Take many hours, many days. But there are some tags here we can use. I've zoomed into one measurement tag. And as you can see, we have tags for GPS, for power, carrier to noise, and MER. I'm mostly interested in these two values, GPS and power. So I went there. I drove the roads in the village, and I made a recording on the ProMax. And when I came back looking at the XML file, I thought, can I use AI to help me with this? Is it possible to visualize, to easily see where the coverage could be bad? I was listening to the radio, so I had a couple of drops, so I knew where it could be bad. So I asked myself, can I get AI to show me the GPS points? Can I get AI to show me the power levels? And can I get AI to colorize the different power levels so I can easily see where or if there are bad coverage? I first tried with a free version of ChatGPT 3.5. It would not upload the XML file. Then I paid for an upgrade to ChatGPT 4. And now I'm going to show you a screen recording on how I got a map from this XML file. So upload the file here. I ask GPT to analyze the file, and it quite quickly realized, I saw the different tags. And I ask it to make a map and colorize the GPS points based on the power values and the values we have set for reception. Sometimes it fails. I give an error message, and it realizes itself that it's something wrong there, and it continues to analyze the file. Sometimes I have to ask it to try again, and it tries again. Basically having a conversation with ChatGPT. And it should not be polite. It's a machine. So be clear, be more demanding than polite. Not write, can you please? Say do, and can you, not can you, but analyze this file, not please analyze this file. And I have speeded up the recording a bit. The recording itself was 17 minutes, I think. So now I got the first map, and it did what I asked for, but it still doesn't mean much if you haven't seen the original map, because you can't see the roads, you can't see where people live here. I ask it to only show the black dots. That means areas with no colors, no coverage. And then I ask it, can you show this on a better map like OpenStreetView? So I got the link to an HTML file. I open the file. I zoom in, and I get the black dots on the part of the road where we had dropouts on the radio in the car. I'll go back to ChatGPT. And I want to see the original map with all the colors in OpenStreetMap. And that's it. The conclusion here, the guy who complained that he couldn't receive anything on his farm, he had a headset radio. And we know by experience they are really bad, most of them. And he also had a really cheap radio in his kitchen. So when we came there with a radio we knew was good, we walked around everywhere where he took us and says, here it's no reception, in here it's no reception. Our ordinary 100 euro radio worked all the time. So we gave him that radio. And those 100 to 200 meters where we had dropouts, there's a road, there's not that many people living there, so we couldn't defend the costs of putting up a transmitter, a new transmitter there.
So yes, I'm Yoann Queret. I'm working with DAB now from more than 10 years. In 20 minutes, I could not go into details, but I will try to give the main information. Digris start to broadcast in Switzerland, after in France, and from the last years in the UK. We operate at this time 43 MUX 90 DAB transmitter on more than 600 services. This represents a big infrastructure over 3 countries. So first, I will introduce you to the digris infrastructure, and after I will talk about monitoring. All the digris LN is hosted in a tier 3 data center where we run space and bring all our equipment. A tier 3 data center is a multipass for power, for cooling, and all system in place, meaning that the server, network and system can remain online during planned maintenance or unplanned outage. The data center provides all the physical access security, UPS, electricity, everything. For us, operating a DAB network over 3 countries essentially means managing an IP network. You will perhaps understand more why on the next slide. We have our ES with the RIPE, we have our IP, we manage our transit, our peering, to be able to optimize the routing for DAB broadcast. Because all the equipment is not foolproof, and because we have a centralized architecture, this architecture is completely redundant. We have different paths for all optical fiber. We have different paths for electricity, and all equipment, core router, switch, server, everything is duplicate. All the server, all the equipment have double attach for network and also for electricity in case we have a problem on one path. The weather map, you can see it's a real one. You can show all the network link for all equipment have minimum double attach. So everything is blank because all equipment are attached with 2 times 10 gigabytes. And for audio, we don't need 10 gigabytes, but from the EDN, so from the multiplexer, we feed all the digris sites over 3 countries over internet. So on this schematic, you can see each digris site establish a VPN connection here between the LN, where you have the multiplexer, and the site where you have the transmitter. This VPN allows us to have access remotely to all equipment for the remote access and also for the monitoring. On digris site, we feed all the transmitter with EDI over TCP, not over UDP, because we have internet in the middle, and to have a robust transport over internet, it's not possible with UDP. Because we also have to provide EDI to other broadcasters, we have some dedicated link to feed EDI over UDP directly. This dedicated link can be dark fiber or Ethernet over MPLS. And today we start to test SRT protocol because SRT start to become a standard. It's not a standard, but start to become. And some manufacturers now are starting to integrate it natively. So on the next slide, we start to speak about the monitoring. On broadcast site, we have the network router, we have our EDI gateway, and for sure the DAB transmitter, and we use also a UPS. As I explained, all the sites are connected to ZN with a VPN, which allows us to query all of the equipment from the ZN. Which sensor we monitor on equipment on site. On a transmitter, we retrieve for sure the forward power, the reflected power. But we also monitor some part of the transmitter, like the fan speed, the final stage current. Everything we can monitor, every sensor we can retrieve, we try to retrieve it if it's relevant. On the router, we monitor the interface status. If we have an interface going down, it's interesting to have the information. On our EDI gateway, we monitor the input, so the signal received from the multiplex. We also monitor the output. If we have a discontinuity in the EDI sent to the transmitter, we have the information. So if this discontinuity is just one packet, it's not relevant. But if you are many packet discontinuity, it's important to have the information. On the UPS, we have an important information because it's a remote site. The voltage information you have in the input, also the output. And we monitor the temperature of the battery and also the autonomy of the battery. We monitor many things, but because we speak local and small DAB installation, perhaps the most important information we can monitor is your transmitter transmit at the nominal power. When you receive an alarm because you are not at the nominal power with your transmitter, you can easily connect on it to know where is the problem. Can be a problem with the EDI audio contribution, can be too much reflected power, a power fault, or another information you can have into the log. I think it's the minimum, but when you have 100 transmitter to monitor, it's useful to have a central place to have the information. To collect all this information, We use Zabbix. It's an open source but very useful and flexible tools. About Zabbix, we build one template for each type of equipment to take each MIB into consideration. For example, when we have one template for SIS transmitter version 1, we also have a template for SIS transmitter version 2, because MIB, it's not totally, but some important part of the MIB, it's totally different. We have the same, we have many templates for different manufacturer brand of transmitter like GetSert, Redes, Plish, and all network equipment we use. This template means when we have to add a new equipment, we just have to select the good template into Zabbix. And internally, the template after can automatically discover if your transmitter use one or more than one amplifier, for example. The big part of the job is to create the template for sure. To collect the information with Zabbix on all equipment, we use SNMP protocol because it's the only one protocol available on every network and broadcast equipment. We are able to take a JSON file with many information into to parse, etc. Zabbix can do it, but the only protocol we can use with all network and broadcast equipments at this time is SNMP. Once collect, all the data are stored into a database with different retention on granularity depending on the data. For example, it's not interesting to keep a granularity of 1 minute during 1 year for the fan rotation speed. It's not relevant. It's not interesting to have this information during 1 year. Globally, we have 2 years history with different granularity depending on the data. With all the data stored into the database, we have some trigger. One trigger can use one or more than one collected data to verify a status and generate an alarm if necessary with different severity information, warning, average, or disaster. Disaster, we don't have many. I don't see any alarm disaster arrive, but we have some. I just now want to show you what we can have into a template. It's a very small part of a trigger. It's an example which allows us to know if a TREDES transmitter in an SFN configuration playing in the right timing. It's important when you have more than one transmitter. If you have one transmitter not playing in the good timing, it can disturb the other transmitter. All of this, of course, is in a template. We don't have to write every time. So here you can see, we check first if the transmitter running in SFN, it's information collected on the transmitter. If it's in a MFN, so not in a SFN, it's not necessary to take care about this timing. If it's in SFN, we have to add the margin to the processing delay. If the result is lower than a minimum value or higher than a maximum value, we can trigger an alarm because we are not in the good timing, and we can after decide what we have to do. The alerting now, it's still also with Zabbix. All events from trigger can be sent to user via different communication channel. It's very, very flexible. You can use Slack, email, Telegram, SMS Pager, or internal tools. You can do what you want. An event can be also escalated with or after a duration. For example, if you have a trigger, an alarm from 1 year ago and still here, you can escalate this alarm to another team, or you can do the same if the severity change to a higher one. The monitoring can, with all the data we collect, we are able to anticipate a large part of problem. On this example, you have one transmitter with 3 amplifiers, 1, 2, 3, and on each amplifier you have 3 final stage. If the current on the final stage begin to become unbalanced, it's often a warning signal when a pallet starts to be defective, and we can anticipate to change the transmitter and repair the existing one. The anticipation, yes. It's not very useful during this winter period, but it's important very for us to monitor the temperature of all equipment. In some special situation, as you can see, this is already allowed us to detect problem with fan cooling on the room due to dead mouse blocked into the ventilator. And you see on we have the normal temperature here, and day after day it starts to increase. And we decide to go on site to see what is the problem, because it's not related with the external temperature, and we discover some problem. Yeah.
Thanks, Hans. Thanks to all earlier speakers as well for their interesting input. Great to be with you. My name is Christian. I'm from Media Broadcast in Germany, and I'm the responsible product manager for DAB+. Well, product manager, we in Switzerland, maybe you can call them the Swiss knife within the company. Maybe the guys and girls, of course, with most interfaces inside and outside the company, whether it's shareholders, stakeholders, customers, the executive board, finance and controlling, purchasing department, sales department, technical department, engineering, and of course, the service operations guys, which finally are responsible for monitoring a national DAB network. Yeah, just let me lose a couple of words to Media Broadcast. We are a company with a long history in broadcasting industry, coming up from the German National Post and being part of the German Telekom, more precise T-Systems. We nowadays are part of the Freenet Group, and we are Germany's largest full service provider in broadcast industries. Our headquarters is in Cologne in Western Germany, where you could find me also if you want to, but you could find any employee of Media Broadcast across the country, as we have there about 600 guys all over Germany. We are the market leaders in DVB-T2 and DAB+, while operating and maintaining more than 700 transmitters. Well, we create platforms for the media. We plan, build, and run them. We, as a service provider, are a B2B company, but we are also a B2C company, for example, with our product, Freenet TV, you might know. Our focus is squarely on digital terrestrials, as I said, market leader for DAB+ and DVB-T2. And modestly, maybe you could say that we have been a pioneer in developing DAB and DVB-T in Germany. We consider ourselves also the backbone of the media, thanks to our high available fiber optic networks. And we consider ourselves also as pioneers in developing new broadcasting technologies, such as 5G, where we have been one of the first companies in Germany to put on a campus network into operations. Now, coming back to DAB+ and national multiplexes, in Germany, we have 2 national multiplexes. Both are operated by Media Broadcast. The first national multiplex is a single frequency network transmitted via the channel 5C. Actually, we have 165 transmitters on air. With those, we cover about 90% of the people indoor. And we cover about 98% of the landscape and 99% of the motorways. Nevertheless, 5 more sites are to come in 2024. And I think there will be a couple of transmitters in the future also to fill some gaps. On the other side, we have the second national multiplex. Actually, we have 82 transmitters on air there. We are covering with those 55 million people indoor, and mobile-wise, about 80% of the landscape and 90% of the motorways. This year, there are going to come 9 more sites here for this multiplex. The second national multiplex is a multiple frequency network. We are using there mainly 4 channels. Meanwhile, as I said, the first one is a single frequency network. And beside this difference, we have also a difference in the customer structure of both multiplexes. The first national multiplex is a mixed multiplex of private commercial broadcasters as well as public broadcaster. Meanwhile, the second multiplex is just and only a private commercial multiplex. So that's the reason why this second national multiplex is focused on metropolitan areas. Both multiplexes are operated in protection level 3A. And we have, in this moment, no bid free. So a great success for DAB there in Germany. Well, what is happening there in DAB+ in those networks? You see here in a simplified description, of course, the production line. We have 5 superior production steps for DAB+, the contribution lines, everything about the head end with its main component, the multiplexers, distribution lines, the transmitters, of course, and the access to the antenna, of course, and everything in both national multiplexes is backed. So we have the main line via Usingen, close to Frankfurt in Western Germany. And we have the backup line via Hamburg in the northern part of Germany. So you have geographically separated production lines, and you have also physically separated production ways. Generally, we have availability of 99.99%, and that's also thanks to quite good monitoring. Well, monitoring, I think you can say that there are 2 major tasks for monitoring. One is, of course, the technical way of monitoring the production line I've shown, but also you need to have a fluent communication to your customer. And for that, we have an own network operating center, and here are some facts and figures about it. We have, of course, the first level support with about 15 full-time employees in a 3-shift operation systems. We have a second support system with about 16 guys also, and we have a service desk with 4 full-time employees, so that we are guaranteeing an availability and reachability of 24 hours a day, 7 days per week, 365 days per year. The colleagues there are handling about 4,000 incoming calls with 3,200 incidents with a quite high reachability. More than 97% of the calls are taken within the first 30 seconds. The guys are monitoring about 27,000 components with 96,000 services, and that on 2,600 sites. So to be the voice to the customer, the guys there have to be quite good qualified. Not only the components which are developing all over the time, such as Cisco components, but also process-wise, for example, ITIL processes. A consistent quality of loops with provisioners, providers and customers is natural. Yeah, what are those guys doing? I think I made it clear. They are receiving the incoming incidents, they are analyzing them, they qualify them, they need to understand the critical status of an incoming incident and to document it. And the most important thing, as I said, is to maintain a continuous communication to the customer, but also to everybody affected within the company. So they need to give the initial information, intermediate informations, as well as hopefully the closing information. Now, on the technical part of the monitoring, we are using a service model which is fully automated, and we are monitoring every single step of the production line I've shown before, the contribution lines, the head-end distribution, and the transmitters, of course, of every single program on every single site. So that makes us quite comfortable with the database we are using and makes us quite quick and safe. How does this look like? Here is a screenshot of our broad fault management system. You see the both production lines. The first one via Using, as I said, close to Frankfurt, and the second one via Hamburg. And what you are monitoring, well, you see every single encoder, decoder, the input signal, you see the status of the up and down links, as well as the routers and the switches, their status, of course, the input signal on the multiplexer, as well as its output signal. The close redundant line is also monitored, of course, with the single switches and the settings of those, as well as the input signal on the transmitter side. And last but not least, the broadcast signal of the transmitter. Now, what is maybe the difference between monitoring a regional local network, which we are also operating, and the national network? Well, the magic here inside is to maintain the guard interval. And as you've seen, the first national multiplex in Germany has 165 transmitters. Every single transmitter that is coming on the net maybe needs to adjust the complete setting of the network. And we have talked about it before, 2 main parameters, the power of every transmitter, as well as their timings. So in this screenshot, you see a coverage point of the first national multiplex and an incoming signal of 8 transmitters, everyone is fine there. The main server and the main transmitter is within the guard interval. How do we manage that and how do we monitor it? Well, we have around about 70 sites across the country where we have installed monitoring receivers. We are working with edge probes so that every frequency fault is detected immediately. How does ends everything? That is the view to the customer. Beside the voice via the network operating center, the customer is able to have a look on the status of the multiplex, in this case of the first national one. He can check the status of the contribution lines, of the head end, the multiplexes, distribution lines, as well as the transmitters. He can check, for example, if he goes with the cursor to Berlin, what's the status of Berlin? If there's an incident, he can check whether it's due to the contribution line or to the transmitter. And you can see maybe that we are working there in this moment via the backup line. Now, here in this moment, everything is green, that's fine. If it would be red, then there is no signal, of course. So, thanks for your attention. Hope I gave some useful information.